what we're going to work on is how to write chemical formulas when you're given ions. Now, what we're going to work with first here is, let's say we're given a sodium ion and we're given a fluoride ion. Now, when we put these ions together, as long as they're forming a neutral compound, their charges should add up to be 0. When we write the formula, we always write the cation first because it is the least electronegative, and we write the anion second. Now, to get the charges to balance out, the easiest way is to use the crisscross method. Sodium has a +1 charge. So that 1 that's here comes across and becomes the subscript for the fluorine here. The fluorine has a -1 charge. This 1 for the -1 comes down and becomes the subscript for the fluorine, or the sodium. This gives us a formula of NaF. Now we can check that by simply looking at the charges and adding them up. I have 1 sodium with a +1 charge plus 1 fluoride with a -1 charge. And when I add those charges up, you find that they equal 0. Now this is what it should be. Now let's say we use a little bit different set of ions. Let's use the copper 2 ion and the chloride ion. Now, using the crisscross method, I always list them cation first, second anion. The 2 for the copper becomes the subscript for the chloride. The 1 for the chloride becomes the subscript for the copper. This gives us a formula of CuCl2. Again, we can check their charges. I have 1 copper with a +2 charge, plus 2 chlorides, each with a -1 charge. When I add those up, I find again that they equal 0. They cancel each other out and become neutral. We can also do this with polyatomic ions. For example, let's say I use the strontium ion, which has a +2 charge, and I use the nitrate polyatomic ion, which has a -1 charge. Again, I can use the crisscross method. I list them cation first, anion second. The 2 for the strontium becomes the subscript for the nitrate. The 1 for the nitrate becomes the subscript for the strontium. So my formula becomes Sr, but to show that there is 2 NO3s, 2 nitrates, I have to put the nitrate polyatomic in brackets or parentheses and then show the subscript. So it becomes SrNO3 2. Again, I can check their charges. 1 strontium with a +2 charge, plus 2 nitrates, each with a -1 charge, adds up to be 0. Alright, let's try one more. Let's say we have the aluminum ion, which has a +3 charge, and the sulfate polyatomic, which has a -2. I can use the same method that I used before. The 3 of the aluminum becomes the subscript for the sulfate. The 2 for the sulfate becomes the subscript for the aluminum. And my formula becomes Al2SO4 in parentheses 3. Again, if I check their charges, I have 2 aluminums, each with a +3 charge, plus 2 sulfates. So I'm sorry, I have 3 sulfates, each with a -2 charge. When I add those up, they add up to be 0. So what we have now is a neutral compound, which is what we want. And this is how we make chemical formulas from ions.